let's see if I can get out of this without, well, actually I'm basically done. So what are the applications? Allows users to specify ID requirements. This is kind of an important thing because when you want a device that provides particular functions, you can provide an SCL file and you've eliminated any ambiguity about how many measurement units it has to support, what kind of attributes you expect to see in the device. You can provide that SCL file, go out to bid for it, and you don't have anybody arguing about whether or not you spec'd it right. It's right there in the file. Vendors can very clearly identify what the capabilities of their devices are. If you look at two different ICD files, the IED capability descriptions, you can see one device supports 8 differential blocks, one only supports 4. You know if you need 6 for your application, you know which device you're going to have to use. You can configure the clients. This is a very handy little tool where you can take an IEC 61850 client, import the CID file, and as far as the client is concerned, it has everything it needs to know to communicate to the device, even though the device may not be present. So this allows you to build screens, get some of the HMI work done without necessarily having all the devices present. And also to be able to, and this is I think the most important thing, is to be able to bring the configuration of the devices in with the power system design and provide an environment where you can manage these things together so that instead of just having a device that's out here that has dealt with in a completely separate manner, you can integrate that with power system design and keep the two in sync. So if somebody on the settings side changes, that can get associated back into the power system design. So it's a way, again, of impacting the process of how these things work together in a very positive way so that you can improve the way we do business and improve how we deploy and build automation systems. So, finished right on time. What do you know?
Thank you.
Okay.
So we're going to have a short panel now, so please, Wahid,
okay.
Ron, would you mind coming up? Mark Adamian, would you mind coming up, please, since you have been contributing to these presentations as well. We have 3 microphones, so you guys will have to share 2. You can use one for the audience to ask questions. So now it's your time to ask questions. The other thing I want to emphasize is that all the presentation will be posted on the NASPI website. Okay. So please. Maybe we'd like to record questions as well.
Maybe I ask a stupid question, so don't record it. I came from University of Tennessee. We are basically working cooperating with the current that group, but we are on research on wireless communication. So my question is this protocol, this whole design, is there any consideration to implement in a wireless communication basis?
Yeah, there's, oh, hello. I guess this doesn't work after all. Talking all that time and it didn't even work.
That's going for the videos today.
Oh, okay, I see, okay. Yeah, actually, the protocols are chosen specifically so that you can run these things over wireless networks. We're trying, we didn't create anything custom and different for 61850 profile that would prevent you from using over wireless. So it uses RFC 1006 is a protocol that works over TCP, and anything that can take a TCP socket, a TCP packet can handle 61850 ACSI services.
And I will comment real quickly. We've actually done testing of Goose over Ethernet over an ISM band. So mapping the Ethernet frame into ISM, we're able to do end-to-end communications of about 20 milliseconds using the ISM bandwidth.
Carl Reinhardt, University of Illinois, TSIP-G. A couple questions. One is that you've laid out some interesting things on paper. Have these things actually been implemented in a software program, and how widely have they been implemented?
Well, yeah. Take that first. Sure.
Do I have to have both?
Yeah, this is for the video.
I think during the part 2 of this afternoon's presentations, you're going to see, as I mentioned during the introduction, you will see both nationally and internationally very large-scale deployments. So I think for now, I'll just say that they're widely used. There's a lot more to be done. There are some challenges also from a practitioner point of view that I'll share with you as we get into the part 2. But it's just a matter of a learning, and once you get into trying to sort of mimic what you have in a wired environment, and how do I translate that into a 61850 application. But yeah, there'll be several examples this afternoon as part of part 2.
Just one more thought to contribute to that. Christoph Bruner's in the room. He's convener of Working Group 10, so his middle name is 61850. I asked him a little while ago how many substations in the world he estimated would have some component of 61850, and the rest of the world is some areas are way ahead of us, and so there's thousands of installations, like 5,000-ish installations, something in that range in the world. Now, the method of adoption implementation may be a little bit different. There's some differences, and there are some challenges that we are addressing in North America and in Europe, for example, that go along with this, but there's a tremendous amount of experience in other areas of the world with it. So.
In some sense, you didn't answer my question, because I'm thinking of, say, Microsoft. Microsoft has implemented things like this.
So the question is, you get a software producer that does an implementation, and then another one that he takes a written standard, he does another implementation. How many people have implemented? Do we go out and buy them from the Microsoft of this? And then are there compatibility issues?
Question: which vendors have implemented 61850 interoperability?
Well, yeah, I mean,
Implemented, and what are the issues?
I don't know. I mean, there's probably 500 vendors easy that have products available worldwide that implement 61850. I guess, I mean, top of my head, there's probably, 20 different implementations out there. There's regular interoperability testing that occurs, sponsored by UCA. And generally, there's a very high level of interoperability between these devices. Some of the challenges that Ron's referring to have been challenges more about the interchangeability of devices, not the interoperability of devices. Interoperability is very high. Sometimes devices out of the box come configured differently, and something just happened here. Well, devices come configured differently, so sometimes there's some engineering work that's required to, have these things match up. But that's, that's typical of any. You buy vendor A, vendor B, you're always going to have some of that. They all have different ways of doing things, and you have to adapt to that. 61850 makes them communicate to each other. It doesn't make the products interchangeable. So, but there's some challenges about that. There's some vendors that think, or some users that think things should be interchangeable. There's probably more vendors who think things shouldn't be interchangeable. So that's, I think, natural tension as the standard gets deployed.
There's nobody else, I guess.
Okay.
Go for it.
So now I'm a power engineer, so you'll have to excuse my lack of knowledge on the computer engineering side. But as I'm thinking about this, I'm thinking of the analogy. This is really plug and play, or implement a plug and play standard. Okay, and then the other thing is that, I look at aircraft and I think of, fly-by-wire, as opposed to having a hydraulic control. What we're doing is we're flying by the wire, and are those appropriate ways to think about this?
The answer is yes. We often speak of, especially with Goose, having virtual wiring where one Goose message can replace literally hundreds of copper wires in a substation. Additionally, with process bus, where today there are literally tons of copper in the ground from the circuit breaker into the control house, this is all being replaced right now by a couple of fiber cables, bringing all the information, measurement information from the yard into the control house.
Any other questions?
Is there network security associated with the process bus?
Depends on the architecture.
Yeah, I mean, the standard exists. The implementers have chosen not to implement the secure functions that do authentication and such. There's concerns about the processing power required to support authentication of these packets. I know, as you'll see later with the 90-5 presentation Mark's going to give, the security is built in, it's baked in, it's inherently secure, and it's only secured. So that kind of technology is coming, where we're, instead of using the asymmetrical key approach of the existing process bus technology on Ethernet, going to symmetrical key approaches that are more effective and easier to implement.
I'm a power system guy, and I've been asked to develop application to suppress wiring. Is there anybody who can help me to do the programming? Very basic. I have all the equipment to do so.
Well, I'm sure there's lots of people that'd be willing to help you. That's a good commercial question. Actually, Christoph, it's part of his business, so. Christoph over here is a world-renowned consultant in that area, and I think you'll see him. He'll be speaking a little bit later here. I'd catch him afterwards and talk to him about that. He advises people on how to implement those things.
Let me just add one thing to that. I think you said you have your product, so I think the first thing would be to work with your product solution provider. They know their products. They can help you. If it does support 61850, they're very familiar with the standard because they've implemented it. So that would be the first thing. If you're looking for how do I design a larger scale architecture for an enterprise solution, then of course you need a lot of subject matter experts and what are you trying to do, and try to focus it on different components. So it really has to do with if your application is basic, the first thing is to work with your solution provider because they're familiar with their own product.
Okay, we have time for probably one more question.
And this is for the fellow who asked the question about wireless implementation. I believe you said you're at Tennessee. Coincidentally, there's a fellow by the name of Wayne Mangus, M-A-N-G-E-S, at Oak Ridge National Laboratory, who's done a ton of research on wireless communications and control system environments. And I think you're in the same neighborhood. He's a splendid fellow. He would be a good one to talk to. He's come up with a number of things in the wireless world that are counterintuitive. It's not what you would expect.
Okay, let me actually ask one question myself here, because I see lots of existing and potential users of the technology. So I think it would be good to answer a question. If users want to upgrade their, let's say, substation from legacy to 61850, what is the process? What is the effort required to make it happen?
I guess try to hold both mics here. Just hang on. It's a dexterity test for the people up here. There we go. There's a number of considerations. The first off is what are the basically to plan out what the migration is going to be. And from a standards point of view, there is a lot of activity addressing that. Specifically, 1815 or DNP, which has a very large following in North America. We are close to complete a very comprehensive mapping standard called 1815.1. We're about to go out optimistically to recirculation, which means we've gone through the first 390 comments, which is really good in this case. We expect to have it published Q2 of next year. very, very detailed. Christoph's involved, a number of others in the room are involved in this. That's going to be a key method going forward, and where that technology will be implemented is in a gateway, mapping from one device to the other, both ways. And we recognize that that's going to be a long-term solution. There's a similar kind of a requirement, of course, for synchrophaser data, mapping from 118.2 to 6159-5, and so there's another activity, part of the implementation agreement, and possibly a new task force that'll be addressing that. So lots and lots of work and thought going into solving that question.
I think, yeah, and just very briefly, if somebody's particularly interested in this, to just pop me a message and I can send you a more detailed presentation that does an illustration of how 6150 components apply to migration issues regarding moving from legacy equipment into a 61850 environment and how that can happen in steps. We just don't have enough time to cover everything here today.
Okay, yes.
I don't know if this is going to Well, just to make sure that your question is answered, most of our projects, I say our meaning we live in the utility environment, are not greenfield. And I want to make sure that the impression is not there that, at least the question wasn't that I want to completely resurface my substation. How do I do this? Your application, so you can take smaller steps. You don't have to convert the entire substation. But my recommendation to those of you who want to do this is really you need very skilled, extremely familiar persons with your existing infrastructure. How is your substation is designed? Ralph mentioned one word which I'm sure you're going to hear a number of times later on. It's called interlocking. Okay, those interlockings are messages, whether it's a Goose message or otherwise. But yeah, the impression, I hope Demir did not leave the impression that you want to convert the entire substation. It could be just the application within the substation.
Okay, the last question.
Yeah, my question goes to, from the ISO standpoint, where they don't own any equipment, their interest is wide area visualization. What's the business case for the ISOs to push for conversion to 61850?
Yep.
So coming up next, we're going to be talking about the new, when you start looking at what are called use cases, I have a synchrophaser. In fact, NASPI brings this out in what's called NASPI net. NASPI net concept says I have one publisher of information and many, many devices that want to receive this information. So going forward, so that this is a use case, a requirement. How do we implement this? 61850 has answered the call and has put forth a solution toward this one publish once, receive many architecture. So from an implementation perspective, there's a significant advantage in the implementation of this enhanced publish subscriber for synchrophasers, as one example.
He wanted to say something too. Got it here. Another thought, just it took me a second to get through it, but is there's a new guideline and object model definition for DER, and so one of the challenges that ISOs are facing is the degree of distributed energy resources there is on the network. Now there's the potential for aggregation and so on of that data, but there's going to be a very high need for ISOs to have visibility on how much DER there is and where. And there's another example along the same lines of what Mark was saying with synchrophaser data.
I was going to stay quiet, but over time, probably 61850 is going to be a lot more broader usage. So at some point, the producer of data may not really have the means to produce the data in a different format. There are solutions. You can put gateway, I think was one of the comments that Ron made. So there may be patches, if you would, but the best thing really to do is to if you can deploy it, the incentive would be ease of termination, ease of acceptance, and then, of course, the publisher subscriber that Mark mentioned. So.
Okay, thank you. Alison?
Before we take a break, to make two announcements, but I want to start by let's thank this great panel and everybody who contributed to the slides. We're going to take a break, and we will, and we need to be back at 3:15, please, to keep things on track. For those of you who drove and parked in this building, in order to get a discounted rate going out, please say, I'm with NERC or the NASPI group and the parking attendant. So you don't need a special pass, you need a special password. And that is NERC or NASPI, and the parking attendant will give you a discount on whatever the published rate is. So let's go get some refreshments, and we'll see you back at 3:15. Thank you.